totally worth it. Alright, so let's talk about the plan for next couple of days. I only see you guys for like 24 minutes a day for the next 3 days, which is like ridiculously short. So really short videos if you're at North Central, East End, and wherever the heck else this video goes to. So, homework for the next 2 nights is to make corrections to the multiple choice part of the test. You have the multiple choice test in front of you. You also have the answer key. And you might be like, but I don't know which ones I got right or I got wrong. That's why you have the answer key. Okay, so for those of you that didn't circle answers in your test booklet, you know, whoever you might be, we can figure it out. Okay, if you do not know which ones you got wrong because you didn't bother circling answers in your test booklet, shoot me an email. I will let you know which ones you missed, and we'll go from there. But it's due Friday, all the corrections. You're not just going to write down, oh, number 8 is B and number 12 is J. I already know that. I want to see you work through this. And this will be a way to review kind of where we are.
Can we do it in the test or? Can
you do it in the test? I prefer that you do it on a separate sheet of paper. It'll be clearer for me to see like, oh, here's your new work. Okay? In terms of free response, we're going to go over question number 1 in class right now, which is why you need your calculator. And we're just going to go over it step by step and see what went wrong. We are not going to spend any time in class on questions 2 or 3. They tended to be much higher scoring questions. This weekend's homework is going to be for you to make the corrections to questions 2 and 3. And I'll offer support if necessary, but I bet we won't need as much. Palomone, if you wouldn't mind coming on back here, you're going to drive the laptop. And we really need to go quickly. Let me take his test. We're going to go from there. Alrighty, and switching to PC. Oh, it's been such a while. Come on now. Oh, pictures of stuff we've done. Always a treat. There we go. PC. Here we go. Here we go. Perfect. All right, Steven, if I'm over here, can all the friends see?
Definitely.
All right. So here's the thing. If, as we're going over Part A, if you don't need to go over Part A, if you earned all the points on Part A, feel free to use this time to work on the multiple choice corrections. Okay. All right. So Part A, not horrible, just not as strong as I wanted it to be. Andrew, can you read Part A?
The total amount of water removed from tank when measured in liters can be determined by using, I forgot how to say that.
It's the definite integral.
Yeah, from the interval 0 to 8 of RT from the DT.
Yeah.
Using 4 rectangles and the less endpoint approximate the value of the definite integral from 0 to 8 of t dt. Determine whether your estimate is an underestimate or overestimate to the exact value.
Okay. So let's see. We've got 4 rectangles. And let's talk about mistake number 1. Mistake number 1, how wide is each rectangle? It's not 2.
1, 2, 3, 2.
It changes. This is not a uniform partition. So if you're going to do this, and you need to make sure that we're using the left endpoint method. So the left endpoint method, that first rectangle, how wide is it? How tall is it? That first rectangle that goes from 0, 1,340 to 1, 1,190, how wide is that rectangle?
1.
Right, it has a width of 1, and how tall is it?
1,300.
It's 1,340. Shame on the teenager that wrote 1 times f of 0. Myra, what's the problem with using 1 times f of 0? Why would you not ever want to do that here? Why wouldn't you do 1 times f of 0? Because the function's name is not f. Lewis, what is the function's name?
R.
R. Not 1 times f of 0, 1 times r of 0 plus. Myra, tell me about that next rectangle. That next rectangle goes from 1 to 3. How wide is it? How tall is it?
2 times r of 1.
2 times r of 1. Giselle, tell me about that next rectangle. How wide, how tall?
3 times 950.
Okay, 3 times 950 or 3 times r of 3 works. And David, tell me about that last rectangle. How wide, how tall?
2.
Okay, it has a width of 2. How tall?
R of 6.
R of 6, which we know is going to be 740. You would get 1 point for the setup, and then can somebody tell me what was the right number answer?
8,000.
8,000,
50.
8,050, 8050? Okay, and the units have to be, right, if the length of each rectangle is measured in hours and the height of each rectangle is liters per hour, hours times liters per hour has to be 8,050 liters, which hopefully makes sense because this is supposed to be telling us how much water has leaked out. It's going to be an answer in liters. Now here is the kiss of death. Is this an overestimate or an underestimate? The most popular wrong answer looks something like this. I plotted my points. Wait. Wow, that would be really bad. I plotted my points, and my points do something like this. And I know that with the left endpoint method, that the left endpoint method has to be giving me a, what is this going to be?
Overestimate.
An overestimate. And saying overestimate is correct. It is an overestimate. The justification was lethal. Why overestimate? My favorite wrong answer. Because I know the graph is concave up. It has nothing to do with the way that the graph is concaving. It has to do with something else we know for sure about the function. It's not just about these 4 points. What do we know about the function? The function is decreasing. And you might be like, how the heck am I supposed to know the function is decreasing? Line 2. The function is decreasing. So no matter how I'm going to draw my graph, these points are going to have to be decreasing without mentioning that it's an overestimate, without mentioning because r of t is decreasing. On 0 to 8, you cannot get the points for that. So it was 1 point for the setup, 1 point for the units here, number with the unit, and then 1 point for it's an overestimate because r of t is decreasing. That was mission critical. David, are you praying? Okay, and I also realized it's been 2.5 weeks since you guys have seen this test, and you haven't thought about calculus over the break, except maybe Stephen, who probably like binge watched all of you too. So there we go. All right, B was a little bit friendlier. Why don't you take a minute and look over part B. Palamon, if you could type that function into the calculator for part B. Yep. Yep, that was a thing. Alright, height of the water in tank 2 is modeled by a differentiable function. H is measured in meters. T is measured in hours. We've got h prime of t. Great. When the height of the water in tank 2 is h meters, the volume can be determined by this guy here. At what rate is the volume of water in tank 2 changing at time t equals 0? What rate is the volume changing? What is it that I'm actually asking for here? This is dV dt. So I need dV dt, and specifically I need it at the time when t is equal to 0. Derivative here, if I'm going to find dV dt, okay, got to be really careful where we're going to take the derivative here. 1/3 pi h cubed. The derivative of 1/3 pi h cubed? The 1/3 and the pi are constants. Leave them alone. Derivative of h cubed? Derivative of h cubed, gotta be careful here. It's gonna be 3h squared.
Times DHDT.
Why?
Because of the, the one with the mom and the baby.
Okay, somebody not named Celeste. Why DHDT? Why are we multiplying by DHDT here?
It's a parent function.
It's a what?
Parent function.
It's not that it's a parent function. We're looking at volume V, we're looking at height H, and these both depend on what variable? Time. They're changing with respect to time. So the derivative of volume is dV dt. We're measuring this change. The derivative of h cubed is going to be 3h squared, but h is a function of time, and so Celeste, your point was like it's that like baby and mama thing. It's the chain rule. H depends on t, so I'm going to have to multiply by dh dt. So to figure out dV dt at t equals 0, well, we've got 1/3, we've got pi, we've got 3. I need to know the height at time 0. What the heck is the height at time 0? Go back and read that question. What's the height at time 0? Myra, what's the height at time 0 going to be?
25 meters.
It's going to be 25 meters, right? They told you that in the body of the problem. So this guy I could just say is 25 squared. I also need dH dt at t equals 0. Where's that going to come from? How would I ever figure out dH dt at time 0? What did they tell you? dH dt is another way to say derivative. They told us what h prime of t is. So what I need is h prime of 0. If you've already graphed it on your calculator, like Polymon has, right, this is the graph of h prime or dH dt. H prime of 0 should be -4. And at that point, there is no need to multiply out any of those numbers. They're all numbers. It's a waste of time to do any multiplication here. You do have to make sure you give me the right units, though. Have a conversation with somebody near you. Remember, the units, they all come from over here. What are the units going to have to be? Where are those units coming from? If you pay attention to the derivative expression on the left, all the units are right here. We're measuring how volume changes over time. How do I measure volume? What are we measuring volume here in this problem? Andrew knows? Andrew, what are we measuring volume in?
Meters cube
And what are we measuring time in?
hour.
So the units are going to have to be
Meter.
meters cubed per hour. Which hopefully makes sense. 1/3 and pi, those don't have any units. 3 doesn't have any units. H is your height, so that's going to be measured in meters squared. dH dt is going to be meters per hour, so everything kind of hangs together. When we were awarding points, it was 1 point if you found the correct derivative, 1 point for plugging everything in correctly, whether you simplified or not was irrelevant, and then 1 point for the units. My thought, the expectation when I wrote parts A and part B is that those would be really high scoring questions or high scoring parts to the question. Part C I knew was going to be rough. So for part C, let's spend the rest of the time talking about part C. If you haven't turned your calculator on, if you haven't graphed h prime of t, now would be a good time to do that, please. Alright, C. What is the minimum height of the water in tank 2 during the time period 0 to 24? This one's a 4-point question. So minimum height on the interval 0 to 24. Do you have your calculator? Get mine, please. Okay. All right, so this question specifically says minimum height. Turn that off. What kind of minimum are we talking about? There's two kinds of minimums that we know. Relative minimum and absolute minimum. What is the minimum height of the water in tank 2 during this time period? This has to be absolute minimum. And as soon as you get like the idea, you're like, absolute minimum. First step, find the candidate. Where might the tank have an absolute minimum? What does it take to have a minimum height or to have a candidate for the minimum height? I'm going to look for where you could either say it's where the height changes from decreasing to increasing. Another way to say that is when h prime makes a change. What's the change for h prime? H prime has to make a change from negative to positive. Is there a time where h prime makes a change from negative to positive? Right, on the interval 0 to 24, and Polymo, thank you for setting the right window here. You're only looking from 0 to 24. There is a place where that change happens. That change is happening wherever this root happens to be. I let you have the root on that one. 6.264. Okay, coming up with the candidate, 1 point. Now I realize on part C, I think this was the part that was a little bit dirty. Because I remember watching you guys in the cafeteria and I was like, hey, time's up. And some of you had like just started on part C. Or something like that. All right, so we've got the candidate. The next thing. You've identified the candidate. The next thing that you have to do. We have to prove that this actually is where the minimum height is going to occur, and you need to find the minimum height. So some of you all, you went through and you said, okay, I know what to do. I'm going to make my table. Here's T. And then what I need is I need to know what is the height at that particular time at this 6.264. Determining the height at 6.264 is part of what we need to do, but it's not the whole thing. Because the other place that you need to check the height is going to be at your endpoints of 0 and 24. Coming up with the height at time 0, hopefully not too terribly bad. Height at time 0 they gave us earlier was that 25 meters? Okay. The height at 6.264 though, you know you've got the graph of h prime, and you know what the height is at time 0. The way that you're going to find the height at 6.264, you know the height at one other time. You know how the height changes over time. How am I going to find the height at 6.264? Little something called fundamental theorem of calculus. So the height at 6.264 is going to be 25, the initial height, plus your definite integral from 0 to 6.264 of h prime of t dt. 261? 261. Okay, sorry about that. 6.261, 6.261. You're going to find the height at 24 as well, so 25 plus the integral from 0 to 24 of h prime of t dt. Use your calculator, get those answers for me. This was one way to go about determining when the minimum height occurs and what is the minimum height. I just want to make sure you guys are getting the right number values. Polymo, if you could you do on the calculator, that'd be great. David. Hi. You need to sit up or do something or get some water. Yeah, why don't you do that? Careful, it's 6.261. Yeah, just delete out or dismiss all. Okay, so according to Polymon, 16.338. Can somebody confirm that? 16.338. Okay. Height at time 24. You could now hold Polymon. Hold on. Polymon, can you hit escape a couple of times? Okay. You could go and you could retype this whole thing, or if you really want to use your calculator in a clever way, arrow up. No. Go back over here, Polymon. Okay, and then arrow up. Like this little guy here. Go up twice. Once to the answer. Once to that, hit enter. That's like your copy paste feature on the calculator. Just real quick, and then change it so that we're doing 25 plus the integral from 0 to 24. And you're going to hit enter, and you're going to get 34.562. That was one way to go about doing this. Real quick, what's the other way? Hello, can you get the graph back up there? What's the other way to convince me right now? Palomon, getting the graph back. One more time. The graph of H prime makes one change only on the interval. And that change is from negative to positive. So this isn't just relative minimum. It's an absolute minimum. By doing that, you'd still have to use your fundamental theorem of calculus, but you don't have to go the other step of testing the endpoints. The reason I want you guys to work in the multiple choice correction site tomorrow, I think that's going to clear out some of the calculus cobwebs that are formed. See you guys in a little while.